understood.
For the well testing, we are focusing on the Paleocene sandstone on the well 1 and well 5. We did a lot of QC data. For example, in this one, the drawdown is not reliable, even if flow at constantly, because they change the separator pressure. So on our analysis, we are focusing on the build-up analysis. On well 1, on the ST5 and the ST1, we quite have really clear MTR to analyze the permeability and skin. The next one, on well 5, we found minus half slope. That means we have the spherical fold from the limited entry or partial limitation. And on the SC5, we have really clear MTR as well 1, but on the ST3, the MTR is quite not good to analyze. The next one. And here is the summary of the DST test on Paleocene sandstone, Jurassic, and the dolomite. On the Paleocene sandstone, we conclude that the permeability is from 100 to 350 millidarcy and skin is from 2 to 8.4. The initial reservoir pressure is around 3,750 psi. No sealing fall and boundary were observed, as I described before. For the Jurassic sandstone, it's not easy to conclude the above permeabilities, as we found that on two wells we have quite different in permeability. But we still have to analyze on the geology later on. But only thing we found that this is an oil reservoir, and we observed
unsealing fault.
Yeah, around 150 feet from the well. And the dolomite, we can analyze the dolomite sandstone from this one because we don't have any data. But we confirm that this is an oil reservoir, and we observe some certain level of H2S. And this is the comparison of a permeability on well testing and core analysis. We found that the geometric and we found that the arithmetic average is quite reliable to use on the average method.
Mm-hmm.
So this is the summary of our fluid properties and reservoir description. Basically, the records were taken from 5 well tests, and the average was like we have given 3,748 psi, and the temperature, the maximum temperature recorded was 242.3 Fahrenheit. From the DVT data analysis, the bubble point pressure was 1,721. Is there any average?
It's PSIG, yeah.
Yeah, but I'm not sure about the reading, but the maximum, you have different values for the bubble point pressure.
No, yeah, we had for different PVTI, but this is for well number 2, right? This data is from well 2, isn't it?
Yeah.
Yeah.
I think gas oil ratio is 300 something.
500.
It's 513, yeah.
500.
I mean, the one that you use in that one as well, let's not go into detail. Let's continue. We will discuss that later.
Yes. So on the average oil formation factor 1.34, and the gas oil ratio, as you can see, is 530. The oil density was measured at the temperature and surface temperature, and the surface condition was 0.8628, and the oil viscosity was 0.77 centipoise. Next, please. This is the top one recorded from two wells, that's well 5 and well 1. The top, I think we need to label this.
It's
well.
down there. Just check the color and the.
Yeah. Well 5, that's the bottom one for well 5 reading, and for the well 1 was the upper one. As you can see, the highest point pure was around 141. Yes.
You need the bubble point or you need the reservoir
That's
pressure?
the formation, 105. Yeah, that's the reservoir pressure.
Yeah, that's the reservoir pressure.
Yeah, so this is the range of our PO
Mm-hmm.
from 1.37
37 to 41
to 141.
to 41. Yeah.
Yeah, and this is the average would be like 1.39. And we'll include that in the assertive analysis for calculating the sewage as well. Next, please. For determining the fascias in our reservoir, we analyzed the core samples for in well 2, 10 core samples, and as you can see, the J function shows that the reservoir has mainly single fascias, which is represented by the top one. And do we need to?
Yeah, we have. Just talk about it.
Yeah, and the only sample which shows a different fascias was the bottom one.
Core 8, sample 8.
Which is,
Yeah.
which is obtained from core 8.
Mm-hmm.
Next, please.
What's the difference between left and right?
But
What's the left and right?
There's no difference. What's happened is I just put it just to show well the which cores are those. Normally there's no difference, because what happened is that we made the mistake. The first graph should be PC versus saturation. Then we would have the J function. You see, right? But we didn't plot the PC versus the saturation plot. But the stuff is almost the same.
what we do?
Huh?
I think we looked that.
Nah, he did straight J function. He didn't plot PC. You didn't plot PC? Nah, I saw it. I went through it. Because when I was doing the report, is one of the things that I have to check. There was no PC. But the graph is going to look almost the same. The only thing is that you're not going to have from 0 to 300. You will have from like 0 to probably
Would be
40 or 50
saturation
something.
versus the capillary pressure.
Yeah, we don't
The
have
shape
that.
Would be the same, right?
Yeah, the graphs will be the same.
Only the coordinates would be different.
Yeah. Yeah, they will be the same. Because I tried to plot it, but the thing is I was so lazy to plot everything. I was like,
Okay.
I
So,
think we should delete the left one
okay, delete one.
because it's the same.
It's the same, yeah.
Yeah, the same, just
Don't
double.
need to.
Yeah, the thing that I wanted to, because on that one
this
I
is
put,
the normalized one.
yeah,
Because we mentioned the normalized
Yeah,
one.
yeah.
in this
Yeah.
scale,
and there I put the legend. You see, right? What happened is that for in yours, because what happened is that I couldn't find this graph in yours, so I couldn't edit it directly. So I had to put the legend. Like now you know which depth is it, which porosity, which permeability you have in the legend.
Because it's part only for determining the normalized one, like
Yeah.
the average one we're going to use in distributing the water saturation around the reservoir. You see the red one, that's the average, and will be used in the simulation.
I think for this one we want to show that we have only one phase sheet and
Mainly,
the average one can represent.
mainly 2 pages.
We have two faces, but
We
we
have
two,
the one
but
Yeah.
represented by the
focusing
red
on
one.
one.
yeah, because we don't have data on the second one.
Yeah, but
We
the
don't
one
have
for
relative
analyzing
variability data.
The second fascias was not enough.
Mhm.
That's why we consider our reservoir
Majority
with
of-
the single fascias.
Majority of our reservoir is only one phase sheet.
Yeah,
Yeah.
The majority is
within this
that
range.
one.
Mm-hmm.
Okay.
We use the correlations for normalizing the fluid property.